Okay, so I want everyone to please focus on the board. So basically, we'll be looking at radian measure, like I said, and I'm going to just follow through with the textbook so we can save time, because it's well illustrated there. So for most parts of this topic, we will be considering this blue textbook. Now there are some aspects of trig that I've skipped, which we might encounter in problem solving. But I don't think we should waste our time reminding ourselves of IGCSE topics. For example, sine and cosine rule, elevation and depression, they are part of the topics. I think they are like the first 4, first 5. You have a problem with those topics? If you do, you might have to catch up later, but I don't think we should waste time because we don't have time for something serious, let alone something not serious. That's the way I look at it. So I'm going to have to prioritize here. Those topics are IGCSE topics, so that's why I've skipped them. Like angle in a triangle, sine theta is O over H. I'm not going to waste like 2 weeks learning something that has been done in previous years. You get my point, guys? But over time, I'll come up with worksheets. I will give you, so if anybody has forgotten something, you can pick it from there. But I'm not going to waste the whole class teaching that because we don't have the time. So, now there are 2 ways to discuss angle, the degree and the radian. And everyone is used to degree all along from our elementary stage. Regardless, I don't care when you started learning about angles, but all you've been learning is degree, not radian. So when you get to a certain position, a certain point in high school or middle school, then the word radian comes up, and that's what we are discussing today. So radian measure is another one. Okay, we can just look at this intro here, which makes so much sense. Now it says we have seen previously that one full resolution is 360, and the angle on the straight line is 180. This is obvious fact. Hence, 1 degree can be defined as 1 over 3/16 of 1 revolution. I think this is trivial, right? The measure of the angle is commonly used by whatever. Now, minute is another angle. I've used that before in some previous calculation, but it's just for you to be aware. The greater accuracy, we can define 1 minute. We define as 1 minute. It's written as that, okay? And that is 1 over 160. Which is 1 over 160 of a degree. Okay, 1 minute is like that, how do I say? The 60th fraction, so to speak. And second, of course, is the fraction of a minute. That's why you have that. But that's not the point here. You can always use a calculator, because there are instructions if you want to convert from one to another. So, for example, we use Casio. I don't remember this, it might change. We use Casio mostly. So I'm happy to send this to you. This is how you convert from the degrees to minute and seconds. So you can check that. I can send this to our group as well. I'll download the PDF and send to our WeChat group. You can save it. Because you'll be using this in calculations, so you really want to know how it is done. So you can check for one of them, for example, if you want, or you can just wait later, I send it to you guys. So let's continue. So calculator instruction later. Now, we're going to do some demonstration on how the radian thing works. But this is the history between the radian measure. This is the history. Now, an arc length. Let's look at this demo. It's easier to look at with this demonstration. You see, in calculations we're about to do, the conversion between the radian and the degree is that our 2 pi is 360 degrees. One complete resolution is this 2 pi. This is the angle on the straight line in radian measure. So this is radian measure, this is degree measure. Okay? And when an angle is in radian, minute is this, seconds is that, in radian is just a small c. That's why I was shocked when he's asking me that, oh, is this degree? I thought everybody knows this. That shouldn't have been something that would come up at all. But if this is the one you're talking about, then I can entertain that. But asking if C is degree, that was so annoying to me. Now, let's see how this makes sense in this picture. So everybody, just look at the board. The radian unit is defined such that on the unit circle, 1 radian is subtended by 1 arc length. So let's see how this works. Let's drag this point. It's too small, right? This will be big enough for us. Okay. Let's see. If the angle, okay, yes. No, go back. Yeah. What did I do?
Well, just Control Z.
I don't think that was it. Yeah. Okay, let's see, come right here. Now, I have to go to the next first. Okay, yes. So, can you see this? Now, let's move. When you have nothing, of course, it's nothing. Now, look at this. I'm going to stop at 90. Let's see. At least these are angles that we know. Angle 90 is pi over 2 radian. In terms of degree, it is 90. In terms of radian, it is that. And the arc length is 3.19. 3.519, I'm sorry. Now, if my radius, of course, is 2 point. Let's see if we can drag the radius to 1 unit and see something. Because we operate this mostly when you have a circle of radius, a unit circle. A unit circle is a circle with radius 1. Can you see it? What do you notice? If the unit circle is of radius 1, the arc length is close to that, approximately. Let's go to the bigger one. Did you see? So this measure is such that the length of that arc is the same as the angle with which it's sustained. It's just to make calculation easier, basically. If you have a unit circle, you see, when the arc length was 3.142, the measure was pi. And of course, we all know pi is 3.142. So this is what the idea behind radian. That is what you saw in this history. This is what this history is talking about. Suppose the arc length is formed by an angle. Suppose the arc length formed by an angle is the same what? Length as the radius. This is the idea behind radian measure. Okay? The angle you form is 1 radian, denoted by that 1c. So the idea of radian measurement is based on this principle. So if you move close to like 360, for example, which is 2 pi in degrees, and you could see that 3.142 times 2 gives that as well. That is why we say that 2 pi is 360 degrees. Okay? Everything is based on a unit circle. But if you do not have a unit circle, when I say unit circle, I mean a circle of radius 1. If you do not have a unit circle, then we can look at the generalization by considering the 2 pi, whatever equivalent. But if you have a unit circle, the length is just the angle. That's it. Does it make sense? So all we have to remember is the conversion. Okay? All we have to remember is the conversion. You can read more from your textbook. So here is the conversion. I'm just going to go through with this. You always remember this. Pi radian is equivalent to 180 degrees. That's all you have to remember. Okay? Pi in radian is equivalent to 180 degrees. And with that, you can do your conversion. So if you're converting forward, where does this come from? It's simple arithmetic, ratio. Your idea of ratio. If I remember that pi is equivalent to 180 degrees, this is my radian, this is my degree. If you ask me, given x radian, what will it be in degree? Okay, so I don't know what this is it. So what it is in degree is unknown, so I put a box there. But the value to substitute is x radian. Easy, cross multiply. I do unknown times pi equals 180x. right? It's ratio. I hope some of you solve ratio question this one. I don't know. But this is how I solve ratio question growing up. You just put the equivalent, then you will do cross multiply. Okay? Because if they are equivalent, it means their ratio is also equivalent. So it's like a fraction. This over this equals this over this. You get my point? For example, if you have 4 is equivalent to maybe 2 times 2, and maybe 8, no. If 4 people spend 12 more, so let's say one person spend 3 more, right? Then 10 people spend how much? 30 more. Is that not? So let's see. Is 4 over 10 the same as 12 over 30? Divide by 6. What do you have? No, divide by 3. Do you see? It works, right? So that is why we always try to think of it as a fraction and cross multiply if they are equivalent. So if you are working on something like this, just use this cross multiplication and solve. You don't have to think of, oh, I'm going to divide and multiply by something. Just write it out and see it yourself. Hello, am I making sense? So the unknown in this case is going to be 180 times pi times x divided by pi. That is why we say it is more or less 180 divided by pi multiplied by whatever you need to change. And this is what happened here. And if you are converting from radian to degree, remember, the x is in radian, I want to figure out the degree. So what I'm trying to say is you do not need to memorize this. You don't need to memorize, oh, going forward is multiply, coming backward is that. You don't need to memorize that. This is all you need to remember. Okay, sorry. Oh, yeah, this is all you need to remember. That pi in radian is 180 degrees. Work it out in terms of ratio yourself, and you're good. Because trying to memorize this can be confusing. But they look similar, so sometimes you don't know which one is which. Am I making sense? Okay, so let's move on quickly. So I won't recommend you do that. Of course, we can test it with even this example. So let's write, for example, radian degree measure. Like I said, all you have to remember is pi in radian is 180 in degrees. So when you press this C, it means, oh, this is radian. This is all you have to remember. So according to this question, we want to convert 45 degrees to radian. I'm not going to go through the way it is done here, because I may not remember next time. Okay? So 45 degrees to radian. So I'm going to say pi equals 180 degree, pi radian. So 45 degrees to radian, it means the radian is unknown. Can you see that? But the degree is 45. Does this make sense? Then I think of cross multiplication. Okay? Then I write, oh, it means 180x equals 45 pi. Then I say x must be 45 pi divided by 180. And most of the time when you are calculating in radian, you leave it in terms of pi, which means you don't use calculator for this pi. Does that make sense? Unless it comes in decimal form itself. So, you do that, what do you get? This is pi divided by 4. Am I making sense? Similarly, for the second part, so because this came in decimal form, so of course it's possible we leave it in decimal. Again, pi radian is equivalent to 180 degrees. This is equivalent. So our degree this time is 126.5. Why this is unknown? So why do we have unknown on the same side? We are converting to radian. Yes. Oh, this is also convert to radian. Can we go to 1 degree question? We can convert it back. Let's say the second question is the reverse of this. Okay? Convert pi over, maybe not pi over 4 this time, pi over 12 to degree. Okay? Convert that to degree. So again, 180 degree is equivalent to pi in radian. It doesn't matter which one comes first, as long as you remember the equivalence. So what do I know? I know this is radian, right? So it's going to come here. Pi over 12. This is radian. If you don't want to put the C, you write the word radian. and this is equivalent to unknown, so I call that y. So if I cross multiply, y times pi equals 180 times pi over 12. So which means y equals, because pi and pi can cancel, right? Then 180 divided by 12 is whatever you get. So if I use 6, I get 30 divided by 2, and that is 15 degrees. Does it make sense? So all you have to remember is this. And that's all about conversion between degree and radian measure. I don't want us to waste too much time on that. I just want us to. So for this activity, we're not going to waste time doing it in class. So I'm just going to, you have your book, or I can just send a screenshot of this to the group on WeChat. Where's our WeChat? Where's our group? I'm sure we spoke yesterday. Okay, I'm just going to send that. So you can try as much as possible. The more practice, maybe the more you remember. That's it. So now this is the important one that we're going to do today. Arc length and area of sector. If you have done sector before, raise your hand. Of course, in degree mode. Something on sector, raise your hand. So area of sector, length of arc of sector. Does anybody know? Not sure? Does it look familiar to you? You think? How about you? Yeah. How about you, man? Okay. But we're not going to assume, deal? Okay, great. So, the thing is, this is what we used to know. But in our radian measure, in this topic, even in calculus, we do not use degree. Okay? In 3, at this level, we do not discuss in degree. We discuss in radian measure. So that's the reason you have to know the conversion between them first. And the rest is just to apply. Okay? And I don't want us to spend more than one class on this place. So that's why the rest is just practice on your own. So arc lengths and area of sector. Of course, let's include perimeter of sector. We know already this, okay, from previous knowledge. We know that length of arc of the sector, okay, from previous knowledge, if theta is in degrees, okay, if theta is in degrees, length of arc is what? Theta over 360 times 2 pi r. Does anybody know why this formula? I want us to just think, so that when you forget, at least you know why this is the formula. Does anybody know why? Okay, let's picture it quickly together here. Everybody pay attention. That's a circle. What is the total angle in a circle? 360. What shape is this? Speak, come on, quickly. What shape is that? This one. What is that shape? Sector. You know it, just say it, come on. Sector, right? Do you agree that a sector is just a fraction of a circle? Yeah. It's just part of it, right? We can say maybe it's 1/3 of it, 1/4 of it, whatever. So if the line was here, what fraction of the circle is this?
1/2.
Speak louder.
1/2.
1/2. Semicircle, right? If this is a straight line, of course, a diameter. If the line was this with angle 90, for example, what fraction of a circle is that? 1/4, which is a quadrant. Now, suppose we just have this. So if I write here, for this one, for example, the area, we always do, half of the area of circle. Do you agree?
Yes.
So if everything here is 25 centimeters squared, then this is 12.5, 12.5. Do you agree? All we just did is half of it. If this was the one in question, you would have said 1/4 of the area of a circle. Okay? Now, we have a sector with an unknown angle or arbitrary angle. When I say arbitrary, it could be any angle, be it the obvious 1/2 or the obvious 1/3 or 1/4. Arbitrary angle. How do we get the fraction involved? The fraction is simply the fraction of its own angle with respect to the total angle. Do you understand that? So if this sector is subtended by angle 90, it means, oh, hello Miss Sector, you took 90 out of the old 360. So you took 1/4. So we measure the fraction you have taken from the circle. Think of it as a pizza, because everybody loves pizza. It's depending on the angle with which you put your knife. Oh, well, pizza is always cut, right? Let's look at cake, for example. If you want to be greedy, you cut so big, yeah? If you don't want like cake, you cut so small. Of course, she said, no, I can't cut small. I know you love cake. We all know you agree with cake. Okay, so it's depending on the angle at the center. If you cut angle 90, it means you have cut 1/4 of it because you cut 90 out of 360. That's the whole idea. So if I cut 90 equivalent, it means I have cut 90 out of 360. So this is the fraction. Fraction of what? Of the area. Fraction of the area. Because the area is by r squared. And this is about the space here. That's the area. How wide is that region? If you're talking about length, talking about this, for example, this is also a fraction of the entire length, which depends on the angle at the center. So if the angle is 90, you have taken, this is everything, if the angle is 90, you have taken 1/4 of the entire length around the circle. And the length around the circle is called the circumference of the circle or the perimeter of the circle. Okay? So that is why the length of arc of the sector is a fraction of the circumference of the circle. And that's why we have this. This is from previous knowledge. So you don't need to memorize. As long as you think of the sector as a fraction of the circle, you are saved. Oh, what is that? Okay. We don't need a break. Thank you. So this is from previous knowledge, okay? And so hence, or maybe we write all the previous knowledge first, which implies that perimeter of a sector now. Remember, a sector is like this. This is the length, this is R, and this is R. Then perimeter of the sector will be 2R plus L, where this is L, okay? This length is L, for example. And area, also from previous knowledge, area is a fraction of the area of a circle. Okay? Now that we know that pi is 180 degree, pi radian, or we could say that 2 pi radian is 360 degree, whichever one, then we can substitute and change this formula into radian measure. And that's what this topic is about, or this chapter or sub-chapter is about. So if that is the case, it means the length of arc of a sector, rather than having theta over 360, it will be theta over 2 pi. The angle over 2 pi times 2 pi r. What do you notice? The length is simply what? Theta r. In radian measure. Okay? The radian measure, the length is theta r. I'm not sure if this is in the formula booklet, but if you can just remember what happened, you are good. Similarly, if you now talk about the perimeter, of course the perimeter remains the same as long as you work out what your length is. But the area of the sector, will be theta over 2 pi times pi r squared. So you see, pi will cancel, theta remains, 2 remains at the bottom also, right? So what you have left here is 1 over 2 theta r squared. Is it? Yes. Does this make sense? And this is the idea we're trying to do. Let me see. Do you see that? So it's just as simple as that. It's based on previous knowledge. Okay? Our length is pi r. It's based on previous knowledge. Just substitution. Okay? If you remember your previous knowledge, substitute the conversion, You don't need to memorize the formula, you're good. So let's apply this in different problems. You can go through the example on your own. I want everybody to quickly, in 5 minutes, I want you to do question 1A, 1C, 2C, and 3B. 1C, 2B, 2C, and 3B. The last question in each. Last question here, last question here, and last question here. Okay, quickly. What? Okay.
You can see the first.
As long as everything can be covered. I think this is how far I can go.
Yeah, I'm scared.
Don't take a picture, pick out your note and work this out.
No, like.
You want the question?
Yeah.
You can send it to the group. Just work this now in class. It's a 5-minute task. It's not homework. Or you can take your textbook and open to that page, 187. The textbooks are here. Lazy boy. Quickly. Because there are more complicated questions, that is just the beginning. Four more minutes. Karen, this is not the time to be slow or copy what is on the board. This is the time to do that task because we're not going to wait. Okay. So I'll send this since most of you don't take your book home. I'll send this to the group. Done. I was going through the past paper and I saw interesting question from the specimen paper on this concept. Actually in paper 3. Yeah, in paper 3. It's a bit complicated because you have to use some trig identities also. You have to, something looks like mathematical induction, but of course the whole thing starts from here. So, are you done? Length of arc is just theta r. Just multiply these two, that shouldn't take time. Area is half theta r squared. Theta is that angle at the center. And you square that, whatever you get. Then the last one, calculate the arc length and area given this and that. So, it shouldn't take time. Most of the work is calculator work. Substitute and calculate. Let's look today what's going on. Let's look today what's going on. This is like something you're kind of writing in exam.
No, it's
1, 2, 3. It's a alien equation. Ready? If you're done with 3, raise your hand. Okay, no one. That's so slow. Is everybody so slow? Okay, so this one. Try not to break out. You just had a good day, so it's not a good time to break out. I'm breaking it in December. Please signify once you're done, please. Done? Stop. When you take your textbook and check 4. Because Mr. Flash, did you get it? Yes, you got it. Can I move to the next page? Or you still need this? What is wrong with parents today? You look lazy. Karen, what's going on?
Here.
You look lazy today. Huh? What's the problem? Sleepy what? There's no coffee. So 4B, once you're done with that, everybody attempt 4B. We're just going to keep practicing. Collaborate among yourselves, ask me questions.